Welcome to Huawei's Digital Power Club Global Tour Europe. Thank you for joining us today. My name is Saida Alam and I am the Marketing Manager Digital Power in Germany. Due to the high-speed development of industries, including 5G, big data centers, AI, industrial internet, UHV and EV chargers, the transformation of society to a digital economy is accelerating. Energy as the infrastructure of the digital world is facing huge challenges. Combining digital technology and power electronic technology, the Huawei Digital Power product line is driving watts by bits. It's leading the digitalization of energy, realizing green power generation and high-efficiency power consumption to build a smart and sustainable world. Today, we would like to invite you to discuss the challenges and opportunities of a digital power world. Meet our industry experts and listen to their thoughts and insights and real-life scenarios. Enjoy! Welcome to today's Smart PV session. Let me first of all introduce Dr. Yangzhou Fang, a Vice President and CMO of the Digital Power product line. In his keynote speech today, he will talk on leading power digitalization for a smart and sustainable world. Welcome on stage, Dr. Fang.
Hello, ladies and gentlemen. My name is Fang Liangzhou, Vice President of Digital Power product line. It is my pleasure to deliver a speech on behalf of Digital Power product line. The topic today is that leading power digitalization for a smart and sustainable world. The main content today includes three parts. What's the scope of the Digital Power product line? Why we can bring more value to our customer through innovative technology? What's the idea and the key value to our customer? European Union declares new objective. Europe will be the first climate neutral continent by the 2050. There are three key steps to reach the target. Firstly, improving energy efficiency and increasing the proportion of the renewable energy. The target is reducing greenhouse gas emission from the transportation, such as increasing the proportion of the electric vehicle. Electric vehicle will be the 40 million by 2030, and charging pills will be 3 million by the 2030. Recently, European region became the largest electric vehicle market than China. Thirdly, using the digital technology such as AI, 5G, cloud, and IoT to improve social work efficiency. Then reducing the greenhouse gas emission. This is a good way to reduce the greenhouse gas emission. Meanwhile, there are also the big power consumption from the digital technology. If there is no control for power consumption from the ICT technology, the power consumption also is increased much more. Huawei is a leading ICT supplier. There are three types of product and solution in Huawei, which is device, connectivity, and computing solution. Although digital technology makes our world better than before, meanwhile, it's also bringing a huge power consumption. According to the third-party report, power consumption from the digital technology, such as telecom site and the data center, shares 3 or 4% total power consumption in the world. So, how to reduce the power consumption is a big challenge for our customer, also to the society. Digital power is a strong power foundation of the digital world. It focuses on energy processing, storage, and conversion with high efficiency. It can help customers reduce the power consumption. Huawei Digital Power product line scope includes two types of scenarios. Firstly, green energy generation. It is a smart PV solution. We provide a solar inverter, intelligent battery, and management system which can yield more green energy. Secondly, high efficiency to use energy, such as a data center facility solution. We provide the power system, cooling system, and the DC management system for the data center, include the big data center and edge data center scenario. Site power facility solution. We provide the rectifier, intelligent lithium battery, and management system for different telecom scenarios, like access site, aggregation room, and central office, and so on. So for M-Power solution, we provide the power system, charging system, and a battery management system for electric vehicle. Modular power, we provide the rectifier module, UPS module, server power module, etc. for different industry. What's the difference between Huawei digital power solution with a traditional power and electronic supplier? We insist continuous innovation on power and electronics industry. Each year, we input 10% of our revenue to R&D department. We have the three kind of key technology to keep us a leading position, which is power electronic technology, telecommunication technology, and AI technology. We introduce the digital technology to traditional power electronics, which can create more value for our customer. Huawei is very strong on the digital technology. Digital power product line take advantage of digital technology. Our advanced power electronics technology can bring high efficiency, high density, and higher reliability for our customer through efficient component, leading topology, and advanced algorithm. For example, high efficiency. Our UPS module efficiency can reach 97.5%. If efficiency is 1% higher than UPS, it means the cost for saving electricity is equal to the cost for the UPS during 10 years lifespan. And also, our solar inverter efficiency is 99%. It's almost the highest efficiency in the world. High density. Our 5G power density is the highest. Traditional 24 kilowatt rectifier is 7 U-head. Our solution is only 3 U-head. And our 1 megawatt UPS is only 1 cabinet. And the traditional UPS need 2 or 3 cabinet. It can save more footprint. Higher reliability. Our solar inverter can access grid even under low SCR situation. Traditional power solution is very difficult on management because it is difficult for digitalization of power electronics equipment and information transmission. We use different transmission technology for short distance and long distance scenario, which make it easy to transmit data between power equipment and managed equipment. For example, we use Zigbee technology to communicate between the battery and power system. We use PLC technology to communicate between the solar inverter and transformer station. We use the IoT technology for the lithium battery. This telecommunication technology are easy to install and also reduce time to the market. AI technology can solve many complicated problems, which is very difficult for the traditional technology to solve. Huawei has a strong AI platform, which already used in different product and solution in Huawei. So we can introduce AI technology to our power and electronic solution to solve some big problem. For example, our smart IV curve, based on the AI technology, can detect 100 megawatt solar plant in 15 minutes. It will take 10 days with 10 people for 10 random inspection for 100 megawatt solar plant if we choose the traditional way. We use eye cooling, also based on the AI technology, for the data center, which can reduce PUE 8 to 15%. It can save electricity a lot. We also use cloud BMS to manage lithium battery, which can improve reliability and capability for the battery. For solar solution, our idea is generating more watt from every PV plant. We lead traditional solar solution to fully digital solar PV plant, which can yield more power and improve O&M efficiency. We change the solar inverter solution from the central inverter to the string inverter. Now almost 62% inverter are string inverter. We also push solar energy from the supplementary energy to the major energy because of lower cost of electricity. For data center solution, our idea is enable more computing power per watt. We make data center simpler than traditional way through the leading architecture innovation. For example, modular power supply, modular cooling system, modular data center, which shorten data center time to the market, and also build a data center on demand, smooth evolution to the future. We also introduce AI tech into the data center facility, which make data center more intelligent. For example, eye cooling technology can reduce the PUE 8% to 15%. Eye power can improve reliability through the predictive maintenance. For site power facility solution, our idea is enables more bits on each watt. We lead transformation from the telecom site to the intelligent site, which makes site solutions simple, high efficiency, and intelligent. We lead the change from the telecom site to the social site, which can provide the power not only for the telecom equipment, but also for family, community, etc., which help our customer to get more revenue and improve profit from the site. For M-Power solution, our idea is a longer cruising range per watt. We push NEV into the digital area with cloud, network, chips, which make NEV more safe and efficient. Our innovative next generation power platform make electrical vehicle simple, safe, good experience, and intelligence. Huawei power solution already serve millions of pieces worldwide. In the past, we only use our modular power for Huawei ICT solution. We don't sell it to the third party. Now our new strategy is Huawei Power Inside. Our partner or customer which need our advanced modular power can cooperate with us. The product includes AC-DC power, DC-DC power, and CT power, IT power, and so on. We also like to cooperate with our partner to create a new area. Our software platform is open. We welcome our partner to develop application based on our software platform. Our hardware modular power support to be integrated. We also welcome ecosystem partner to work together with us and win to win in the future. Our mission is leading power digitalization for a smart and sustainable world. Thank you.
So let's welcome Mr. Gorgon Chen on stage. He's the president of the Digital Power product line. Today, he will give us an overview of the Smart PV business.
Dear friends, welcome to Huawei Smart PV Virtual Summit. Unfortunately, we can't meet in person due to COVID-19, but I hope all of you and your loved ones are staying safe and sound. Today, we are delighted to meet you here through this virtual summit, and together discuss future trends in the PV market with solar industry experts, exchange valuable insight and experience. First, I would like to share Huawei Corporation's semi-annual financial data with you. Despite the challenging time globally, Huawei's revenue increased by 30.1% year-on-year. The total shipment of Huawei Fusion Solar Smart PV solution is 130 gigawatt until June of 2020. We can't achieve such achievement without our customer and partner support. And on behalf of Huawei's team, I would like to say thank you to all of you sincerely. As to our industry, the technology innovation have exceeded expectations in recent years. Utility-level solar power plants are even more competitive than traditional energy sources in most of the regions. Mid-East just broke the record and lowered the price of solar power to 1.3 US cent per kilowatt hour. In Latin America, the rate went down to 1.8 US cent per kilowatt hour. PPA projects are gaining traction in France and Germany as well. And China will also add another 10 gigawatt project free of subsidy this year. The LCOE will continuously decline as all the component costs fall further. How do we stay more competitive in this market? Since 2013, we have been the pioneer to introduce string inverter into large-scale solar plant, along with many smart features like multi-MPPT, power line communication, smart IV curve diagnosis, and smart DC systems. Now, working with more than 3,000 people in digital power R&D team around the world, including Germany, Spain, Japan, and China, we will continue to invest in our international research center and co-innovate with our customers to ensure even lower LCOE, stronger grid support capability, higher safety level, and better experience. In the future, AI will be as ubiquitous as water as electricity. It is a strategic technology that will lead the future, and it is a new core engine that will drive PV industry transformation towards intelligentization and create more value. 2020 will witness the comprehensive integration of cloud, AI, and 5G technologies. As such, we have further integrated AI to enhance the intelligence of our smart PV solution. We can't wait to share more details with you today. Let's work together for our mutual success and bring the smart PV for future vision into reality. I'm looking forward to meeting with you soon. Enjoy the event. Thank you.
Let us now move on to Sam Wilkinson. Sam is Associate Director Clean Technology and Renewables at IHS. Today he wants to talk about COVID-19 and smart PV. How will the solar industry weather the storm? The stage is yours, Sam.
Hi everyone, my name's Sam Wilkinson and I'm delighted to have been invited by Huawei today to share with you some of the latest views from IHS Markit on how COVID-19 is impacting the solar industry. Now 2020 has been a year unlike any other, and the word unprecedented has been used a lot. But I was trying to think if there was any similar things that had ever happened that could, possibly be compared to this. And for some reason, it got me thinking about a very famous scene in the movie Jurassic Park, which I remember very clearly from when I was a kid. And there's a scientist explaining the idea of chaos theory, or the butterfly effect. The idea that a butterfly flapping its wings in one place could change the weather entirely in another place thousands of miles away. Now, who would have thought that just over half a year ago, an outbreak of a virus could actually change the course of history all over the world? So there's been a huge amount of disruption. And I'd like to just share with you some numbers that actually illustrate the level of disruption we're talking about. Just to start with, there is now 18 million confirmed cases of the virus, and that has increased from just 1 million in April. So a huge increase and a rapid acceleration around the world. IHS Markit experts are now forecasting a global decline in GDP of over 6%. That is a huge change to the 2% growth that we saw in 2019. Travel around the world has changed beyond belief. And this number here illustrates that. a 74% drop in commercial flights if we look at April 2020 versus April 2019. But we're not here to talk about these global indicators. We're here to talk about the solar industry. So let's just think a little bit about what has happened in the solar world. First of all, the first impacts of this virus were felt in China. And as China started to shut down in order to try and slow the spread of the virus and control the virus, we saw a major impact on the supply of solar components. Over 70% of polysilicon, wafer, cell and module manufacturing is based in China. So it was easy to see why, with such strong restrictions on logistics and work, that people started to be very concerned about their ability to actually procure all of the components that they required to build projects all over the world. But the situation changed very, very quickly overnight. China was able to control the spread of the virus domestically and began to ease restrictions quite quickly. Production came back. Logistics were able to cope with the increasing demand and actually start to move products around again. But elsewhere in the world, the virus had begun to spread, and very quickly demand from the rest of the world collapsed. As restrictions were placed on how people could move about, where people could work, it was very, very difficult for the solar industry to continue as it had done. So we saw a threat to the production very quickly turn to a collapse on the demand side. What we're starting to see now as restrictions are eased in most places around the world is that momentum is actually starting to build again. And there is great optimism about demand for technologies like solar in the future as part of this potentially green recovery. Now, it is true that the pandemic has impacted different sectors in different ways. The ground mount sector, in some cases, has actually been able to continue almost unaffected. In countries like the US, for example, the market has continued very, very strongly. In other regions, construction of large ground mount projects was halted for a month, maybe two, because people were unable to go to work and it wasn't deemed essential work. The rooftop segment obviously suffered from very similar things. Very, very difficult for people to go and visit people in their homes, visit businesses in order to construct projects or to build plants or to discuss the details. But actually one of the more important things for the rooftop segment will be the economic impact of this pandemic. We're all very aware that this is going to have huge economic repercussions, and so businesses and individuals like you, like I, will potentially be very, very careful with the amount of capital that they're willing to spend. So if I sum up all of that for 2020, IHS Markit is now for the first time actually predicting that global solar demand will decrease in 2020. There is across the board big reductions made to the forecasts for the reasons that I've just discussed. But there's also some slight variations to the trend as well. Actually, the biggest of those variations comes from China. We actually increased our forecast for demand in China when we first made our changes to the forecast in April. The reason we did that was that we were confident and we expected that there would be some policy intervention to help the domestic manufacturers of China and to actually help to stimulate additional demand. In the rest of Asia, we have made some quite large cuts to markets as those restrictions continue to reduce the amount of demand, reduce the amount of installation activity that can happen. For example, we've made quite a significant cut to the Indian market as those restrictions are in place and as international trade becomes more and more challenging. The other big exception was in the USA, where, as I mentioned earlier, we've seen the market continue in a very resilient way. We already predicted very strong growth for the US market ahead of the changes to the ITC, a very policy-driven situation. And we've seen the worker there continue to go, projects continuing to be built. But let's think a little bit more about some of the longer term, bigger picture impacts here, rather than talking about the specific change to megawatts installed in 2020. And there's 4 key themes here that I've picked out. The first one is the big question that we always get asked. With oil prices so low, how can solar compete? And what I would say is that actually what this is doing is highlighting one of the biggest values that solar can offer. Solar, once it's built, has very, very low, very stable, very predictable operational costs. It doesn't rely upon a supply of fuel that can increase in price or decrease in price. It can also see disruption to that supply with the potential for not being able to actually secure enough fuel potentially. So solar can offer something in these times of price volatility. Yes, oil prices have gone down. Oil prices will one day go up. That is certain. So I think that it really does highlight one of the key benefits that solar can offer. Another thing, and I'd like to just talk for a few minutes about this, is that it has also really highlighted some of the digital technologies that has allowed solar to become such an advanced technology that offers low-cost power. So, it's very important when we're here today talking about Huawei technology that we acknowledge that through digital technologies we are able to offer situations and solutions where O&M can actually be carried out from remote locations. Faults can be diagnosed from very, very far away, and we're minimizing the amount of times that people have to visit a plant to actually carry out maintenance. That's probably a reason why string inverters have actually been able to become such a major part of our global industry. And in 2019, string inverters accounted for over half of global shipments, and in the utility scale sector accounted for nearly 40% of shipments. And that's also been a major part of how Huawei has become the largest supplier of PV inverters globally, and has been for the last 5 years. This idea that digital technology can allow solar to continue to improve, continue to be a low O&M, a low OPEX solution is very, very important to the future of solar. We also see a very big trend towards what is being called deglobalization. People are increasingly concerned about ensuring a local supply, and that includes electricity. So again, solar being a technology that once installed doesn't rely upon a continuous supply of fuel is very, very important. So the pandemic is again really highlighting some key benefits of solar technology. The last thing on a more policy focus is that we really do see the possibility that the recovery plans, the stimulus packages that will be required to allow global economies to get back on their feet after this situation, many of them will favour low carbon, clean, renewable technologies, and that may well place solar in a very, very good place for growth again in the future. So finally, to sum all of this up, we do see a big reduction to our previous forecasts for solar deployment in 2020, and the economic challenges that will follow this pandemic will also reduce demand compared to our previous forecasts in 2021. However, we predict that by 2022, solar installations will be back in line with where we had previously forecast them, and therefore we'll see continued growth, and the solar industry continues to be in a very good place with a very, very bright future. And so to conclude, there is huge short-term disruption from COVID-19. However, it really does highlight some of the really key benefits of solar. And again, the digital solutions that are being offered today to allow people to remotely monitor and remotely operate their PV plants are going to be key towards solar being a very highly valued technology in the future. We also believe that solar can play a key role in a green recovery, and we see that the fundamentals for growth remain on track, and that we do think that the market will be back to its previous growth trajectory by 2022. Now, thank you very much for listening, and I hope you enjoy the rest of the event today.
Thank you, Sam. Let's introduce now Mr. Andrea Ronchi on stage. Andrea is the Sales and Marketing Director at Nuo Energy. Today he will talk about how does digitalization enable smart PV projects. Looking forward to your inputs, Andrea.
Hi everybody, I am Andrea Ronchi and I'm the Sales and Marketing Director of Nuo directly from my home office today. First of all, thank you Huawei for inviting us to this nice digital event, and to begin, really 2 words about Nuo, just to better contextualize our today's speech. Nuo is the data science company fully dedicated to the renewable energy sector. We are a corporate startup of the Falk Renewable Group, and we started up in late 2019, so a little bit less than 1 year ago, but today the team is already made of 23 professionals, software developer, data scientists, and renewable asset management experts. Our solutions are already applied to more than 3 gigawatts of wind and solar power plants. We like to say that we combine 3 key elements. The experience of one of the major independent power producers, Falk Renewable, the experience of the world-leading asset management company, Vector Renewable, and the dynamism of a digital startup. The reason why we created Nuo is perfectly in line with the concept of this event. We are all facing a challenge which is probably the most ambitious challenge humanity has ever faced. We need to decarbonize society, and most of all, we must do it in less than 30 years. Energy is of course one of the main pillars of this transition. Therefore, we must all work together in order to speed up the diffusion of renewable energy power plants. But how can we play our role in this plot? First of all, by keeping the profitability of renewable assets as high as possible. And this task is growing in complexity. Market parity, dynamic energy markets, participation to grid balancing schemes, storage, just to quote some example, are making the business model of asset owner more and more challenging. And data, artificial intelligence, and Internet of Things are powerful tools that are empowering asset managers in order to solve and to manage that growing complexity. I would like to give you some examples. Improve production forecasts. Even by keeping weather as an exogenous variable, having a better prediction of your plant availability is going to be the key for the correct withdrawal and dispatching activities and for the participation to the flexibility markets. Predictive maintenance. This is really a buzzword nowadays, but it's crucial on at least 3 different time horizons. Short term. React quickly and possibly avoid emergencies. Midterm, by rescheduling the programmed maintenance activities in order to avoid defaults. Long term, planning the revamping of your assets, prioritizing the intervention based on a given budget and ROI evaluations. Scheduling of hybrid plants. How much and when to store energy, when to use the stored power, how big should be the storage facility. These are heuristic problems in the field of operative research, and artificial intelligence can help us in finding the optimal plans. All these nice use cases are leveraging on data. I think it's worth to spend 1 minute on something that may sound obvious, but in reality is not. The photovoltaic industry is very rich in data, but the data infrastructure is generally a mess. There are no standards, there are thousands of proprietary protocols, there's no harmonization. All this is creating a lot of noise that of course we can use data science to help us in solve it, in harmonizing those data. But would be definitely better to focus the efforts on the final use cases rather than in heavy data cleaning activities. We hope that players like Huawei will find a way to propose and support standards adoptable by all the players in the value chain. Out there is a multitude of data loggers, KDB, etc., which all sounds pretty similar, but in reality they have different logics in behind. And this is slowing down so much the adoption of data science for the final users. In this context, I would really like to give a recommendation to all the investors in greenfield power plants. These are the times you should pay a lot of attention in the data infrastructure. The harmonization of the data coming from all the components of your plants is not less crucial than the choice of the hardware per se, because it's through those data that you will feed the tools that will help you and your asset manager in taking the decision for making your investment profitable. I would also like to make a personal consideration about business models based on data. There is the myth of considering data as the oil of the future, but we all must be aware that data are not solving the problem by themselves. It's how you treat them that actually solves use cases. If everybody is designing business model, pricing every little piece of data that they collect or they manage, at the end of the day, the adoption of data science models leveraging on huge data sets will not be economically worth. So it's going to be a lose-lose game. At Nuo, we think that this is the time for a real collaboration on those aspects, and it would lead definitely to a win-win situation for all the players in the value chain. Talking about collaboration, I'd like to stress one thing that inspired also Nuo's business model. Out there are a lot of extraordinary companies in data science. They may lack no domain know-how, but they are really cutting edge in data modeling. In data science environment, things evolve really fast. So the competitive advantage of who wants to do everything in-house is rather fragile. That's the reason why Nuo wants to be the door to the market for all those innovators that decided to dedicate their data modeling capability to solve problems related to the renewable energy industry. Also because in data science, the one-size-fits-all strategy is often utopian. Customization is likely to be the name of the game. And in this context, sharing the experiences with who knows really the domain is simply the key.
Thanks, Andrea. Next up is my colleague Hariram Subramaniam. He's our CTO of Huawei Fusion Solar in Europe, and today he will talk about the 10 trends of smart PV at 2025. Over to you, Hari.
So good morning, everyone. Welcome to Huawei EcoConnect Europe 2020. And today we will see the 10 trends in smart PV at 2025. So how did we do this? The methodology for coming up with a solution and with an answer for the 10 trends. We worked with quite a lot of stakeholders, research institutes, think tanks, and also our own research here. And we came up with 10 trends that will significantly influence the PV industry in 2025. So let's go through these 10 trends one by one. And in total, the 10 trends can be summarized as the topic respect to digitalization, the topic that will be AI-driven upgrades. So we would see quite a lot of technology in artificial intelligence. We will see unmanned PV plants used basically for O&M applications. We will see proactive support in the grid. That means the inverter will be able to provide quite a lot of technological advancements in control algorithms for grid support.
We will see solar and storage that will join together to bring in also ancillary services. We will see virtual power plants, distributed power plants of PV. That will be quite a lot of power plants combined together as an aggregation unit that will provide quite a lot of energy required to the demand centers. We will see active safety in terms of, let's say, photovoltaic inverters when installed with PV panels in the rooftops. It requires quite a lot of safety and needs protection for people and also for those people who will try to do O&M services. That activities will also happen in 2025, will be ramped up. We will see also from the technological perspective, from the inverter, high power density products. That means going with a high amount of kilowatt per kilogram and kilowatt per liter. We will see modularity in design. Modularity is also in the power electronics, or in terms of the power electronics that goes inside the stacks for the IGBTs and so on, where we will see quite a lot of modular design that will also bring in redundancy and bring high availability to the PV parks. And last but not the least, most important thing is cyber security and trustworthiness, which is very important. And this kind of activities will be quite important in algorithms and in software systems that when the PV plant is connected to the grid. So we will go through these points one by one in detail, and we will see from our perspective what are all the activities and the gamut of things that will be happening in 2025. So for the first trend is digitalization. So what exactly is digitalization? So what exactly is happening here in terms of digitalization? So power systems is a very traditional industry. And in this traditional industry, there are a lot of, let's say, units or conversion systems which are happening with electromechanical systems. So there isn't an amount of intelligence in these systems. So when these kind of power plants, when modernization is happening, we will see a lot of intelligence, we will see connectivity, and this will also bring in a lot of efficiency into the power systems. So that means we will integrate digital technologies, communication technologies like ICT technologies, big data, analytics, and so on into the PV power plant. And we will see that kind of systems will be very helpful in monitoring as well as in communicating with each other to come up with, let's say, for big data decision making and algorithms. So here we will see not just 5G, but also IoT, Internet of Things. We will see also cloud-based technologies that will happen into the power plant, and we are also seeing now a lot of digital customers from our side who are deploying a lot of digital tools and software APIs into the power plant and into systems. So we expect more than 90% of the power plant will become digitalized, let's say around about 2025, and the ramp up has already been started right now as I'm speaking. And what is the logic here? I mean, the logic here is not just, let's say, bringing in communication and connecting things, but also analyzing the data that comes out of the PV plant, and that calls for the second trend. The second trend is AI-driven upgrades. So what is happening here with the AI-driven upgrades is that when a lot of power plants or, let's say, devices provide data, it needs analysis. So it cannot be done manually, so it needs some intelligence, and this intelligence should come from software algorithms and methodologies, and also, let's say, methods that uses learning behaviors or learning patterns and so on. And moreover, we will also see a lot of pattern matching algorithms. We will see cognitive computing that will go inside these technologies, and we will see that these kind of, let's say, learning algorithms will be very effective to come up with a pattern that will be useful for O&M applications, and that will also be used for fault diagnostics, which is very important. If we are talking about 25 years of the lifetime of the power plant, it's very, very important to do this fault diagnostics. And we will also see storage with solar. We're also going with a little bit of AI. That means, for example, for the battery management system, it's also a kind of a management system which also needs to do some computation approach here. This is getting important. And around about 70% of the PV plants, we will see that will adopt AI. And we also see AI for O&M applications. That means finding faults in the panels, finding, let's say, fault in the power systems, in the AC side, and so on. And these kind of activities we will see in the next trend, what is actually happening. That is the unmanned PV plants, the trend 3. Basically, this is a system, or let's say a kind of technology. You can think like robots or kind of also drones that is effectively used for, let's say, O&M applications. And this will also run some algorithms. So if you take actually digitalization, AI-driven upgrades with unmanned PV plants into one picture, you will see there's quite a lot of interaction and interconnection between it, because everything starts from the digitalization process, basically. So what exactly is happening here? We will see O&M, let's say robots, as I said, like drones that will fly, can do electroluminescence, that can also do photoluminescence, and bring in new technology that will help for the asset managers to come up with, let's say, better prediction to understand, let's say, a kind of predictive maintenance and condition-based maintenance when certain things has to be maintained, for example. We would see around about 80% of the power plant will effectively use this kind of unmanned systems. Moreover, all the power plants are remotely located. So that means these power plants are not in a place where you can send people. It could be in the middle of a desert. It could be in the middle of, let's say, nowhere, because most of the power plants are being built there, large-scale power plants. And so this can also reduce the cost of labor and the cost of human being there to do O&M activities, and could be digitalized in a very effective way. And coming now to the most important trend, which is actually the proactive support for grids. So what exactly is this proactive support for grid? As of now, we are looking at a PV inverter. It's just providing, let's say, current to the grid, and the grid voltage is already existing. And we are also seeing a trend that quite a lot of power plants with a lot of renewable penetration, or let's say the power systems with renewable penetration, will see a trend of reducing short circuit ratio, or in other words, technically called as high impedance in the network. So that means the power plant or the control system that is actually driving the power plant through inverter should be able to actually operate also in this kind of low short circuit ratio, or a kind of a weak grid scenario. So that means it is very important to bring in proactiveness into the grid for grid support. The inverters are not just doing a conversion of, let's say, DC to AC, but it is also providing grid support services. It can, in the future, do not just, as I said, as a current source, but can also work as a voltage source and form the grid. That's what we call it as grid forming converters or grid forming inverters. And as you see, the trend is going down very below 2.0 is the short circuit ratio. We will see that in the next 5 years, quite a lot of proactiveness, grid friendliness, control algorithms that will go inside the inverter. And we are already inside this technology right now and providing solutions for a lot of systems around the globe. The important trend, I think people are always talking what's happening with storage, what is happening in terms of electricity, not just from the panels, but also from the battery, how the system can work in a very good coupled way with PV. Definitely for a massive deployment for renewable, when we are talking about 100% of renewables in 2050, and when you are talking about ramping up the renewables in some years, actually storage plays an important role. Definitely it plays a role to provide ancillary services like frequency support if you are looking into it, and also providing, let's say, active power when the frequency is going down and so on. So what is this happening? So there are two different things here. One is technology driven, so that means the storage prices are getting lower, and the other one is actually market driven. Where can this be applied? So storage solution can be applied in terms for not just grid support, but also to do peak shaving and also do arbitrage and so on. So we will see this will also have a lot of penetration. Around about 30% is estimated here that around 2025 will be covered with storage coupled with PV power plants for grid services and also for, let's say, to provide market-driven application like balancing services and so on. Another important topic, I think this topic is not being, currently it's getting trend, virtual power plants, quite a lot of offerings here in virtual power plants in Europe, and also we see this catching outside Europe now. So what are these virtual power plants? So this is a very interesting concept where we can see even a small player who is having a very small generation system, maybe in his home, can join into the PV market or join and go into the exchange. So that means there is a kind of an aggregated system. So when a lot of distributed PV are installed in a kind of, let's say, in community, or it could be also in residential locations, it could all join together and be quite a kind of, let's say, like a swarm with high power, which could also be like a big utility with the same capacity as a big utility. So what is happening here? So this needs a lot of services, applications. We see not only power being transferred, transferred, but we will also see data being transferred and also business being transferred here. So what I mean by business is the transaction, let's say the payment methods and so on with these virtual power plants, where we will have innovation coming through blockchain applications here. So we will see this kind of technology will enable a lot of people to go green and also participate in the market through this aggregated services. And we are seeing quite a rapid progress here in Europe, and we will see a catch in also outside Europe. And we estimate around about 80% of the distributed systems and PV systems will have a lot of, let's say, capabilities to join into the virtual pool, or let's say the pool of PV systems that will enable the digitalization, as well as that will enable a kind of technological impact in bringing renewable into massive scale inside the power systems and the energy grid. Now, important topic is active safety. I mean, safety is the fundamental thing. Whenever people build a power plant, it's very important. So what is active safety? And where does this activeness come actually? So the active safety is one important topic that we call it as the arc fault circuit interrupter, or let's say a kind of a system where there can be, let's say, an effect that will create an arc, maybe because of installation issues. It could also be because of some problems that happens during the lifetime of the project. So these arcs are quite dangerous because it can create a fire. So there needs to be a system that actually detects an arc, and at the same time, the system should not actually detect kind of a noise and think that is also an arc. So there should be a distinguishment between real arcs and actually false positives here. So this is done by kind of an intelligent algorithm, and putting this intelligent algorithm into deep learning kind of system will effectively find a way to think if the arc has really happened, or if it is a real arc, or if it is just a noise in the system, because there is also other power converters and systems that can create certain noise. And the distinguishment and a kind of, let's say, a calculation to come up with the correct prediction is getting more and more important and getting more imperative. And that is the active safety methods. As you can also see in the video here, there's a kind of experiment that is done showing how the arc can really result in some big fire. And when this kind of system is deployed, it's easy also for the firefighters in case they are actually trying to extinguish some fires in the rooftops. It's actually a very easy and simple way, and also protects people and property in this. So this is something that's happening now, and we would also see quite a lot of PV inverters having this AFCI, or the arc fault circuit interrupter, integrated, so there isn't any additional component that is needed. Very important topic, as we have been talking about the system level, let's go a little bit more into the inverter level itself. So the inverter level, if we talk about, is actually power density. So previously people were considering an inverter with very high efficiency, reliability, availability, but what is important is also very high density. So what exactly it means? So as you can see that around 2012, a typical inverter, let's say around 30 kilowatt, was weighing around about 180 kilograms. Yeah, but now we are in a domain where we see in 2020 an inverter is just weighing, I mean, let's say can provide 185 kilowatt, but it just weighs around 83 to 84 kilograms. So that means there has been a trend that has come through microcontroller innovation, signal processing innovation, and also packaging innovation, and also operating at very high switching frequency. So what does this mean? When the power inverter operates at high switching frequency, the magnetics become smaller. When the magnetics get smaller, the power density is improved. The heat dissipation is actually also effectively adapted. And this is bringing in smaller products, easy for installation. This is also bringing in systems that can be easily replaced if there is a failure, because it's not so heavy. So we will see a trend. This brings in semiconductor innovation and technology. That means it's bringing in a concept that might move a little bit away from silicon-based technology to new semiconductor technology like silicon carbide, gallium nitride, and things like that, where we can go into very high switching frequency and bring in high power density into the product. That means more kilowatt can be provided with a lot of, let's say, with small kilograms, and more kilowatt can be provided in some liter kind of. Yeah, that's something very interesting to see how the technology is actually driving here. And the next important thing is modularity. Modularity is very key here, because modularity brings in high availability. So once, as I said, modularity modularity, it's kind of also related to power density, because once the inverter is high dense, and if you can think about a power converter system in kind of a small package, you can also try to put in more of these kind of packages and bring in very high modularity into the system. So the system could be swappable also online. That means even when the power system is working with power electronics, it can be replaced in case of failure, and it can bring in very high amount of availability here. So these are multi-scenario applications that we will see, and we will also see energy storage-based technology will also have this kind of modularity. So a lot of small cells, and cells become packages, and this kind of becomes modules, and then from these modules become, let's say, battery cabinets and racks, and it can also be effectively monitored and be balanced in a very nice way. So this is something that is going to happen, and we would see in 2025 quite a lot of modularity coming also inside the PV inverter from the product side. Last but not the least, a very important topic, and it's called as security and trustworthiness, because the power plant is connected to the grid. There is communication interface. A grid operator can try to speak with the power plant, can reduce power, increase power, and so on. So this brings in a kind of power management and communication that is secure. So that brings in a lot of, let's say, security algorithms and APIs that goes inside the power plant, and that is basically algorithms, mathematical encryption models, and so on. And we will see this kind of needs that might also go into effectively into some grid codes, and that might also go into some requirements on some power plants large scale, because power and energy security is very key, and power plants should be managed in a very effective way. So this is actually what we have also seen. So we will see quite a lot of this algorithms and system software models that goes inside a system of PV inverters and at the power plant level, at the interface level, which will bring in high amounts of cybersecurity and resilience that is needed to the power plants. And thereby saying, I thank you everyone for listening to the trends, and it has been a great pleasure to speak and to see how the future is going to look, and we would like to make the future together with a lot of new innovation and technologies. Thank you very much for listening.
Thanks, Harry. Now we would like to look at our product innovations for 2020. My colleague Chia Bing, Senior Expert of Smart PV Business, will take us through our new PV products and innovative solutions for household owners.
Huawei innovates and optimizes throughout the entire life cycle of PV energy generation. As the largest inverter supplier from 2015 to 2019 globally for 5 consecutive years, Huawei is committed to building efficient, smart O&M, safe, reliable, and grid-supporting smart PV plants, and helping customers maximize the return of investment over the plant's lifetime. In 2020, Huawei will further integrate AI technologies to boost LCOE and accelerate grid parity for all. We are very pleased to welcome Mr. Xie Bin, Senior Expert of Huawei Smart PV Business. He will launch a new solution for residential scenario, and his topic is residential new product launch.
Welcome, ladies and gentlemen, to join our webinar today. It is so great to be here and sharing with you the Huawei new residential product releases. So let's start. Firstly, let me introduce you the brand new Sun 2000 226 KTL L1 Smart Grid Center and the Sun 2000 3-10 KTL M1 Smart Grid Center. It has 2 MPP trackers, which allows it to be installed independently on those simple and neat rooftop. What's more, this second generation Smart Grid Center also has built-in M-bus communication, which in another way, power line communication. It allows optimizers to work with inverters directly. Battery ready. This is a great feature that we had on our first generation Smart Energy Center. And for our second generation, we will also have this fantastic feature. It is a high voltage DC coupled battery interface, which allows to expand to a battery system by simple plug and play. Communication. Huawei Smart Energy Center has built-in WLAN as its default communication, but this year it will also support Ethernet and 4G communication as optional. So for our users, they will have more choices. The second generation Smart Energy Center also has a very compact design. It only weighs 12 kilograms, allowing one person easy installation. Next, let me bring you the second generation SUN 2000 450 watt smart PV optimizers. It is compatible with the previously mentioned inverter models. And one great thing about this optimizer is its one-fits-all feature, which means one optimizer fits almost all poly and mono PV modules in the market. So for our installer friends, they don't need to worry about sourcing different optimizer models to fit different PV modules, because one Huawei optimizer can easily fit all the PV modules in the market. The max power and input voltage for this second generation smart optimizer is 450 watts and 80 volt. So any modules within this range can be easily connected. The max efficiency is 99.5%. In terms of rapid voltage shutdown, during installation or under emergency cases, Huawei's new smart PV optimizer can achieve 0 volt quick voltage shutdown to protect people. In terms of installation, the output cable of Huawei new optimizer is 1.2 meters, allowing modules to be installed in either portrait or landscape mode. Next, let me introduce you the most expected and exciting product, the Huawei Luna 2000 Smart String ESS. Like a string inverter with optimizers to optimize the performance of each PV module, Huawei String ESS also have this fantastic, unique built-in energy optimizer to optimize the charging and discharging performance of each battery module. Huawei Luna 2000 utilizes a modular design solution. Each battery module's capacity is equivalent to 5 kilowatt hours, and users can expand the system up to 3 battery modules, which equivalents to 15 kilowatt hours. And it also supports parallel operating. So with 2 sets of Luna 2000, the total capacity now can reach up to 30 kilowatt hours. A great thing about Huawei Luna 2000 is it also has this one-fits-all feature, which means one battery model to fit Huawei's single-phase and three-phase inverters simultaneously. The power module on top can easily handle 400 or 800 volt high DC voltage coupled systems. The battery chemistry is lithium iron phosphate. The charge and discharge power of one set of Luna 2000 is 5 kilowatt, but it can achieve up to 10 kilowatt if we add another set of Luna 2000. The default installation is floor stand. Relevant floor stand installation parts will be included in the package. Users can also choose wall mount, but it's optional. Optimal electricity cost. At Huawei, we're always thinking about how we can reduce electricity cost for our homeowners. One thing we agree on is for the money our customer invest in the system, we need to generate as much power as possible and help our customer to consume as more power as possible, so we can maximize the PV self-generation and minimize the electricity cost. For complex rooftop with shadings, Huawei recommends our full optimizer solution. Optimizers can help to improve the performance of each PV module independently. And depending on the degree of module mismatch, the energy yields increase can be as high as 30%. We know that during the usage of battery modules, degradation occurs. So for different battery modules, they may have slightly different SOC. Or when we add a new battery module to the existing old system, the SOC difference of this new pack and old pack will be even larger. And if we do nothing in these cases, the charging of a new battery module will be limited by the older and weaker modules. For example, charging to 80% and can never go more. At Huawei, thanks to the built-in energy optimizer, now we can charge each battery module independently, and we can also discharge 100% of its energy when we need it. Homeowners can use the full potential of each battery module for more usable energy. Another great feature is the dual power battery ready feature. So for homeowners who purchase the 5 kTL Huawei residential inverter, if adding 10 kilowatt PV on rooftop with the help of Huawei optimizer long string design, this 5 kilowatt inverter can simultaneously achieve 5 kilowatt full power AC output plus 5 kilowatt full power battery charge. So a 5 kilowatt inverter can get 10 kilowatt in total. It's a very cost-effective deal. active safety. At Huawei, we're always thinking about how we can bring safety of PV system to a next level for our residential users. We perceive that one of the key challenges we're facing is electrical arcing. Electrical arcing is an electrical breakdown of air that produces a prolonged electrical discharge. It normally occurs in unreliable soldered joints within PV modules, broken PV cables, or loosened PV connectors. The danger of electrical arcing is it can easily start a fire, and it is very hard to detect. The arcing signal can be as small as 0.1% when compared to normal current signal. And for this challenge, Huawei has introduced the AI-powered active arcing protection. With this AI mode, or AI brain inside, Huawei inverter is continuously self-learning new arcing features. And when real potential arcing risks occurs, via its local neural network algorithm, it can accurately detect and judge whether it's real or fake arcing. And if it's real arcing, the inverter will shut down immediately. The entire process from detection to make a judgment to shut down the system power takes only around 400 milliseconds, which is well with 0.5 second standard requirements. Seeing is believing, so let's check it out. On my left-hand side is a real arcing simulation in lab without AFCR protection. We can see the DC arcing is continuously posing fire risks. And on my right-hand side, with the same electrical arcing, and if we turn on this AFCR protection, we can see the arcing extinguishes instantly with 0.5 seconds. So is that all about for residential arcing protection? Today, we will bring you a brand new feature, the Pinpoint arc fault positioning. We all know arcing hides below PV modules, but we do not know where the specific location it hides. So conventionally, it may take installers half a day to inspect along the PV strings for troubleshooting. But with Huawei's Pinpoint arc fault positioning, our system will tell you the exact location of this arcing, so installers can well manage the troubleshooting time within half an hour, minimize the power loss caused by arcing system tripping. Another concern is power outage. For Huawei residential system, by installing the backup box, now homeowners can have 5 kilowatts continuous power output to support their critical loads. And the switchover time is less than 3 seconds. Residential PV systems nowadays have many components in the system, like optimizers, battery, meter, and etc. How to easily install become one of the key challenges installers are facing. At Huawei, we're always thinking about how we can improve. So let's check out the video first. Firstly, for the optimizers, we managed to make it 50% smaller than its first generation, thanks to the compact design philosophy. It can now fit in your palm and hold comfortably, helping you to start a great day. With Huawei Fusion Solar app, it can now automatically detect all system components like optimizers, energy storage system, communication dongles, meters, and etc. The only thing we need to do is to click Next Step. The entire process takes only around 1.5 minutes to 3 minutes, which compared to a system made up by different brands, the configuration time may go up to 15 to 20 minutes. So we can save a large amount of time for our installer friends. Less than 5-second module auto mapping with AI. This is one of the best features that I like about our solution. Before, the optimized physical layout creation is all done manually. We need to relate the serial number to the correct module icon in management system one by one. For 15 kilowatt system, it may take up to 6.5 minutes, and may easily make a mistake by relating the optimizer to a wrong PV module. At Huawei, we're doing it all by AI. All you need to do is to take a picture of the template and upload to the management system. And with one click, it can instantly turn into physical layout view, just like magic. And all it takes is 5 seconds. It can save up to 80% configuration time for our installers compared with conventional solutions. One of the key system benefits for Huawei Fusion Solar residential smart PV solution is one fits all, which means one optimizer fits almost all poly and mono PV modules in the market, and one battery model fits all residential inverter models, whether it's single phase or three phase, and one app to detect and configure all affiliated system components automatically, and one device scanning to register whole system components in the PV plant management system, and finally, one service window for all system components. As digital technologies and renewable energies are reshaping the world, we firmly believe that our society will become more intelligent and greener in the coming future. Thank you very much for your time, and have a great day.
Thank you so much, Bing. Now let's move over to the Netherlands and to our colleague Bauke van der Vet. Bauke is our Senior Solution Manager at Huawei Fusion Solar, and today he will talk about how AI drives a fully connected smart PV plant. Over to you, Bauke.
Good afternoon, ladies and gentlemen, and welcome again to join our summit. Over the last few years, artificial intelligence, AI, has become a high-frequency word. AI is enabling us to deal with new challenges and pursue better lives. Even today, during the prevention and control of the COVID-19 pandemic, artificial intelligence is playing a vital role in facilitating virus analysis, drug research and development, intelligent temperature measurement, as well as auxiliary diagnosis. With our long-term experience in designing applications utilizing AI, Huawei now provides Fusion Solar 6.0 Plus utility smart PV solutions. Fusion Solar consists of the 185 kTL smart string inverter, SACU smart array controller for data transmission and control, STS smart transformer station for high voltage connections, and the Fusion Solar Smart PV Management System for real-time monitoring and management. Today, I would like to introduce you to our latest progress and how we deploy artificial intelligence in Fusion Solar. Let's start with Huawei's Smart Tracker Control algorithm. Conventionally, the module tracker system and the inverter are two worlds apart. Inside the tracker controller, conventional astronomical calculations and backtracking algorithms only try to follow the sun regardless the conditions in the plant. In-row shading can occur when the sun is low and the ground uneven. And in cloudy days, the tracking system is trying to follow a sun which isn't even there, and that is hardly the optimal way to harvest energy from the modules, particularly when you are using bifacial panels. So to improve the tracker control, Huawei has integrated AI. We employ a neural network and a self-learning model to continuously sample the sensor data such as voltage, current, irradiation, temperature, wind speed, etc. in real time and locally at the plant. This creates a closed loop between the tracker and the module, and the inverter with the tracker algorithm. For example, in the morning and in the evening, the control algorithm will control each row individually to avoid in-row shading. And when clouds roll in, the algorithm can sense the change in the radiation and figure out that we are now in diffuse light conditions. It automatically repositions the trackers to a new optimum angle that is not necessarily facing the sun to harvest more energy from the diffuse light. We have tested this technology in PV plants in different latitudes all over the Chinese mainland. Results show that compared with standard helioscopic tracking, The smart tracking algorithm can improve energy generation by 0.5 to 1.3%. We have also used AI to reduce O&M complexity and OPEX with smart IV curve analysis. Compared with a conventional solution that uses on-site sampling tests and time-consuming manual analysis, smart IV curve analysis can drastically shorten diagnosis time from weeks to half a day. AI learned this expert knowledge and can accurately identify 14 types of string failures, which is also certified by TÜV. The diagnosis can further provide troubleshooting solutions to close the loop in your O&M process. This function has now been deployed in 5 gigawatts of PV plants worldwide. Huawei continues to upgrade the algorithm to suit more and more scenarios. In this year, the 4th generation can support diagnosis of mono, poly, bifacial and shingled PV modules. And it is also compatible with mixed installations, where different PV modules are in one string or in a Y-branch connection. This year, I am very excited to launch this new AI algorithm on grid connection. As the LCOE of PV continuously decreases, solar is expected to become a major energy source. According to IEA's outlook in 2019, in the near future, over 30% of all newly installed power plants on an annual basis will be a PV plant. However, this influx of renewable energy access is pushing out the traditional generators like thermal power plants in many countries. In addition, PV plants are usually constructed remotely, and they are generally in faraway situations from the power grid with consumers. Therefore, we can find that the short-circuit ratio of some regional power grids will become lower and lower. Or in another way, more and more regions will see a new challenge of the weak grid. And this chart on the right is based on Bloomberg's prediction of renewable energy penetration in several regions. It is expected that between 2025 and 2030, the short-circuit ratio in some countries will be lower than 2. Huawei has been researching the grid connection of PV technology for many years and has invested heavily in the precise insights into the power grid status and improving control accuracy. Currently, Huawei has achieved what we call stable grid connection in all scenarios. The value of this technology to customers is that site selection under the conditions of a changing power grid is not affected. The algorithm supports stable grid connections in weak power grids with a short-circuit ratio down to 1.5, and it improves higher fault ride-through capabilities. At the same time, it improves the power quality by suppressing current harmonics to less than 1%. In the weak grid connection testing, the output waveform of Huawei inverters is still stable when the short-circuit ratio is 1.5. The output waveforms of other string inverters become distorted when the short-circuit ratio is already 3, and the inverters can work only with reduced power or switch even off for self-protection. In terms of power quality, in a real power grid with background harmonics, Huawei inverters can ensure that the THDI, the current harmonic distortion, is less than 1%. In comparison, other string inverters can barely achieve the claimed THDI of less than 3% even in laboratory conditions. In real power grids, the harmonics of such inverters can surge to more than 9%. Besides the testing results, we know that Australia's new standard in February 2019 is the world's most stringent grid standard in the world. Huawei has helped its customers to get the first admission to the new grid standard for an 85 megawatts PV plant in Victoria. The approval time for this project was only 50% compared to other solutions. In China, this year, the Huawei Sun 2000 inverter was the first to meet the new technical requirements for grid-connected inverters, which calls on higher requirements on high voltage ride-through, low voltage ride-through, and frequency adaptation. And another real case occurred in the northeastern China in April this year. A 100 megawatts central PV plant was built and grid connected in the end of last year. Later, a smaller PV plant of 20 megawatts was grid connected nearby, which utilizes Huawei's smart PV solutions as well. In April of this year, a grid fault with a phase-to-phase short circuit occurred and further led to a low voltage condition in this local grid. Both plants managed to stay online and ride through the fault, even in a situation that was far beyond laboratory simulations. So what we learned from this case, for a long-term PV plant operation in a daily changing grid scenario, a grid inverter with a strong grid connection algorithm becomes particularly important. For many rooftop projects, we know that one of the key challenges in building safety is electric arcing. Electric arcing is a breakdown of air that produces a high temperature electrical discharge. It can occur in unreliable soldering joints within the PV modules, in broken PV cables, or in loose PV connectors. Because of the intense temperatures of up to 3000 degrees Celsius, electric arcing can easily start a fire. Moreover, these arcs are very hard to detect, since the arcing signal can be as small as 0.1% compared to the normal voltages and currents inside the PV system. For this challenge, Huawei has introduced the AI-powered active arcing protection last year. Very much similar to how computers can learn to recognize faces, Huawei artificial intelligence is continuously self-learning how to detect the specific signals of electric arcs under any condition. And when a real potential arcing risk occurs, via its local neural networking algorithm, it can accurately detect and judge whether it is a real or false alarm. When a real arc is detected, the inverter will shut down immediately, which will extinguish the arc as well. The entire process, from detection to shutdown system, takes less than half a second, which is well within the standard requirements of 2.5 seconds. The proof of the pudding is in the eating, so let's demonstrate this now. At the left-hand side, we see a real arcing simulation in our lab without AFCI protection. We can see the DC arcing is continuously burning and it is posing a fire risk. On the right-hand side, we turned on the AFCI protection. With the same electric arcing conditions, we can see that the arc extinguishes almost immediately and the inverter is shut down and the monitoring system reports the problem in real time. The system is now safe and a trained installer can now go to the installation to fix the problem and eliminate the risk. As digital technologies and renewable energy are reshaping the world, we firmly believe that our society will become intelligent within the next 3 decades. Powered by AI technologies, the PV industry cannot stay behind, and it will be reconstructed and redefined. In the new world, where everything is sensing, connected and intelligent, solar power will become greener and more vibrant. Thank you for your time.
Thanks, Bauke. Now we're inviting our customers to talk about their approach to a digitalized solar industry. Next up is Mr. Roberto Castilloni, CEO of Ikigai Capital. Roberto, over to you.
Good morning, good afternoon, good evening, depending on where you are and what time you're watching this webinar. Thank you so much for the introduction, and thank you so much, Huawei, for the opportunity to be here today and to be talking about power digitalization to support the energy transition. First of all, I would like to give you a quick description of who I am and my company, Ikigai, so that you get an understanding on where we're coming from today to talk about digitization and digitalization and funding the digitalization, more importantly. Ikigai is a net zero bankability consultancy funded to bridge the gap between the private sector investors, technology, energy-intensive industries, and the public sector. The company was set up by myself and Elena Anderson, the co-founder, towards the end of 2017. And we have today a couple of very important members of the board that help us deliver the energy transition. One of these members is Claire O'Neill, former Claire Perry, former UK Energy Minister and UK Transport Minister, and Lee Hudson, the other director on the board, non-executive director on the board. She's the head of sustainability at IAG and British Airways. Ikigai has 3 different business lines. One is strategic advisory, where we advise investors or large energy users with anything to do with energy transition and net zero capital investment and decarbonization of industrial operation. Then we have a technology accelerator, where we basically enable green technologies, normally with a tested technology, to create a bankable structure around their technology so that they can go out to the market and grow by accessing institutional investor capital. And then we have a development and co-development arm of the company, where basically we aim to deploy technologies and fully fund energy solutions to enable large energy users to decarbonize their operation while we support them in creating profitable business. A bit of story about Ikigai. It's a Japanese word. It comes from Japanese and means the reason for living. And you can see the 4 different values of doing what the world needs, what we're passionate about, where our skill lies, and what generates value. And the 3 arms of the company, they're all working in a complementary fashion, because when we need a technology that comes out of the accelerator that can be deployed into the development side or can be used on the advisory side, and vice versa, the development that normally follows the advisory side and is supported by new technologies. So when we talk about energy transition, we have a unique approach, because we know that energy is not core to a lot of our clients, not core to the industry, but energy is critical. What is core to our clients, to the industry, is profitability and competitiveness. And so how do we decarbonize the operation of the large industries while delivering profitability and competitiveness? We start by doing what are our client-specific priorities. This is what we ask ourselves. And if you can look at the slide now, you can see the energy trilemma, which is basically sustainability of energy resources, profitability of the business, and security in terms of resilience, safety, and cybersecurity of our clients. So where are the priorities for our clients? Then, once we have identified the priorities, we use data. Data is a key factor, and the analysis of data is key to understand the energy DNA of our customers and deliver quick wins. The energy DNA of an industry is basically where energy is used, how energy is used, to understand the very deep usage, fragmented user of energy into any customers. Because it's only by understanding the challenges of using energy that we can actually optimize consumption of energy, i.e. reduce the consumption of energy. And then, only then, we can actually create solutions to deliver decarbonize operation and deliver profitability as a service. It's a bit like going to the doctor, and unless the doctor runs some tests and understands deep down what your symptoms are, he or she will not be able to deliver the proper medicine to cure your issue. And in a way, that's exactly what we do with our clients. We get deep down all the way to the granular consumption of energy to understand how energy is consumed, why and when, in order to create the proper solution. Digitization, automation is key, central to the solutions that we provide. But I believe that digitization should be key to any solutions within the energy transition. And any investor should think about including digitization in any investment opportunity within the infrastructure sector. So, first of all, we're using different nouns: digitization, digitalization, digital transformation. They mean three different things. Digitization, it basically means making things digital. Digitalization is business opportunities created by the digitization. And the digital transformation is changing the business model with digitalization. The digitalization is driven by three main drivers, I think. We have an increased volume of data due to the declining cost of sensor and data storage. It has become extremely easy these days to harvest data, to collect data. The problem is that when you harvest data and when you collect data, you may run the risk of ending up in a data swamp. So it's a pool of data so thick, the information is so thick that you can't actually swim through. And that creates a problem. But of course, when there is a problem, when there is a challenge, there is an opportunity and there is a solution. And advanced analytics is exactly what you need to understand, to sift through the amount of data and understand what the data, what the machines are telling you. And this is why the advancement in machine learning and AI algorithms is making digitalization possible. Also, great connectivity due to faster and cheaper data transmission. Think about 5G. Think about where we were a few years ago, not long ago, 10, 15 years ago with GSM, GPRS module, and now with 5G. The level of information, number of data that you can transmit is tenfold from a few years ago. So more data quicker means that you can analyze things at a deeper level. So digitalization affects and shapes electricity markets, enabling greater renewable energy penetration and moving towards a more distributed system. So the problem that renewable energy is creating is that we're moving away from base load, from the traditional base load, and having a huge amount of electricity coming through the grid at any given moment. Renewable electricity, we know it's quite volatile. It goes up and down depending on solar, sun, and wind. So can we use the digitalization to help us improve the penetration of renewable energy? And we are already seeing how digitization is helping the sector to thrive. For example, helping smart demand response to enhance flexibility. Look at battery storage and look at what the aggregators are doing on using battery storage as an asset. And what battery storage does is basically enhance flexibility in the system and allows more megawatts of renewable energy to be connected into the system. But also, digitization helped to integrate variable renewable energy generation. And we know that we have different sources of renewable energy and different sources that produce energy at different times. Clear example is solar with wind. So how do we manage these two complementary sources of energy living together and creating a reliable grid? Then one important point, and I'll be talking about this later with a case study, digitization is helping the rollout of smart charging technologies for EVs. We'll see how the use of data analytics and the use of machine learning is key to support the rollout of EV charging, and as a consequence, the rollout of electric vehicles in the system. And then think about smart metering. Digitization, or better, digitalization, we have learned now, is facilitating the development of distributed energy resources, especially with regards to household level. And so private generation of solar, private storage for a household, exchange of data, how important it is to understand within the household what consumption profile every family has. Also for the consumer is important to understand. And also with smart homes, imagine how digitization is helping managing the consumption, potentially turning off lights when they're not needed, or turning off temporarily freezers when in peak hours they don't need to be connected, because we know that turning off the freezer for like an hour or two, nothing is going to happen to your food. But if you keep doing it on a daily basis for a year, the amount of energy you save is quite significant. Digital technology, as I said, are widely used in the energy and in the end-use sectors. There are, in the broader sectors, huge advancement of technologies, and digitalization is being used across the board to help achieve significant energy reduction. But because of this, we actually start seeing an excessive use of energy to support the digitalization. And we can't just move towards a direction at the expense of the increase of energy consumption. There are other sectors, key sectors, that we need to decarbonize, and digitization is helping the decarbonization. For example, transportation, whether aviation or, as we know, vehicles, they're moving towards electrification. Some airplanes are already being developed for the short haul. Buildings, important penetration of digitization, as I just said, with IoT and smart metering and smart sensors, and also the industry with IoT, digital twin, machine learning, and remote control operation. So if I can just go through a couple of case studies. What I was just saying, digitization is a two-way street, affecting both the supply and the demand for energy. We are using digitization always more. We're producing more data. We need to save the data. We need to process the data. We need to distribute the data. But this means creating bigger and bigger and bigger and bigger data centers. And data centers are one of the biggest consumers of energy. In fact, it is estimated that in 2019, about 1% of global electricity use was because of data networks. And so on one side, we're using digitization to decarbonize the industry, but then on the other side, we're seeing that actually digitalization is driving electricity demand. And so this is a point that we need to be very careful, because we don't want to solve one problem by creating another problem. Another quick case study is about Mobilize.ai. It's an MIT spin-off from Massachusetts Institute of Technology in Boston. These guys are developing a mobility analytics platform whereby they're using private data and public data to basically create a precise map of where EV charging station should be deployed. It's basically a hot map of where EV charges should be deployed at level of a city, town, council. This will enable a better deployment of EV charging locations and a more profitable deployment of EV charging. And because of that, then if the case study is proven profitable, there will be more investors coming in. But as a consequence, there will also be more people accessing EV charging, and as a consequence, more people buying electric vehicles because they find it easy to charge their vehicle. And so we're creating this virtuous circularity of digitalization, whereby collecting data, but also investing based on data, gives informed decisions to the investors that enable them create profitable investment decisions, that enable them create more data, that then goes into the circle and create the perfect environment to deploy EVs and to move forward with one of the main drivers of the energy transition. So what do we need to do to make the digital transition investable? We need a different approach to project delivery. First of all, we need to have a multi-vector approach. So it's not just electricity, but we need to look at the energy system as a whole: power, heating, cooling, storage, e-fuels, carbon capture. Also, investors, they need to look at a system-based approach where we are technology neutral, where we are demand-led, and when we look at fully integrated solutions, fully integrated systems. We also need to remember that all these solutions, they need to be bankable. So we need to have a proper risk allocation. We need to have, wherever possible, stability of cash flow and visibility of cash flow. And investor needs to be fully aligned with the technology that is a proven technology, because we need to limit, of course, the level of risk that the large amount of money, the large institutional investor can deploy to deliver the energy transition. Obviously, we need to look at the profitability side as well, because we don't believe that you can deliver net zero, you cannot deliver the energy transition unless you're creating value. And you need to create an environment where the investments, they have revenue diversifying qualities. They are value driven. They have resilience qualities and cost savings. So the important and the final point that I want to make is about the focus that we need to have on stranded asset and how digitization can help mitigate the risk around stranded asset. There are a lot of categories of infrastructure, core and core plus, that are running the risk of becoming stranded in the medium to long term. And by using digitization and digitalization, we can help mitigate this risk. Some industries like aviation and shipping, heavy industry, water and waste in particular, where the penetration of digitalization is still low, and industrial clusters, and how industrial clusters can work together in energy clusters that can deliver digitized, affordable, and decarbonized energy. So thank you so much for your attention. I hope I managed to deliver some of the key elements of the digitization of the sector and how the energy sector still needs a lot still needs to do a lot on the digitalization side. And although this is a massive challenge, it also offers a massive opportunities for investment and massive opportunities to deliver the energy transition. Thank you so much for your attention.
Thanks, Roberto. Last but not least, Mr. Benjamin Cott, CEO of Lightsource Lab at Lightsource BP, will talk about his thoughts on delivery energy flexibility and unlock value in grid edge assets. Over to you, Benjamin.
Hello, everyone, and welcome. My name is Benjamin Cott, and I'm the CEO of Lightsource Labs. Lightsource Labs is the technology division and innovation division of Lightsource BP. Lightsource BP is a leading project developer in the solar photovoltaic space, working together in a joint venture with BP. What Lightsource Labs does is we deliver energy flexibility and unlock value in grid edge assets. What does that mean? We provide a connectivity, a smart device that sits between residential solar PV and also industrial solar PV, as well as energy storage and electric vehicle operation. And in that way, it can extract value from the grid and from the energy flows between those devices and between those appliances in order to reduce energy consumption, reduce carbon, and reduce costs. Why is this necessary, or where do we play in the market? So we're really in the middle of the transition from the old style grid, which is really focused on baseload supply, where you have an operator like a utility, generation, and a consumer all connected through the old grid, a linear grid if you want. And we're in the middle, as you can see here on the chart, is in the energy management system area of the new grid, where you have highly distributed renewable energy and storage, as well as multiple devices and much more consumption, highly consuming devices and appliances on the consumer side. For instance, you have local generation through PV, you have electric vehicles, local storage, and so on. Lightsource Labs technology sits in the middle of that and really coordinates the energy flows and the information flows between the consumer in terms of residential and industrial, the grid, generation, and the cloud as well. A little bit of history on Lightsource Labs. We were founded in 2016 when Lightsource BP was working on residential solar projects. Lightsource BP is now working on exclusively ground-mounted large-scale projects, but the project, which is Labs, has kept going. In 2017, we partnered with EDF, where 160 energy customers of EDF received a complete package composed of solar PV, battery storage, as well as our smart hub. And the customers also got a 20-year residential PPA power purchase agreement where they get cheaper energy from Lightsource through the solar PV, and would only have to use grid energy when the battery is fully charged, or when they needed more energy in order to consume it. So the customers benefit from cheap electricity, and the grid benefits from more renewable energy. In 2018, we launched a project together with BP and Tonic Energy called Stronger, where you had a similar setup with prosumers and consumers, so people generating electricity, people consuming it, among a pool of 100 residents. And they were able to do peer-to-peer trades of electricity between those households, which was all certified and settled on the blockchain with blockchain transactions. So quite an advanced pilot, and that ran for a year and just finished. In 2019, we launched our latest generation of our product, which is the Tribe Hub, the home energy management system. This is generation 3. In 2020, as we speak, we're already working on the next generation, which is a new device where the compute unit is separated from the meter unit for more flexibility and the ability to connect multiple meters to the same compute unit, which is launching early next year. A little bit about Lightsource Labs. We have about 30 people worldwide, mainly in 3 offices on the development side, in the UK, in Limerick, in Ireland, as well as in Athens. And we have sales operations in 3 markets, again in the UK, in Spain, and in Australia. In terms of USP or differentiators for Labs, we believe these are centered around three aspects. The first one is that we develop, own, and operate our our own stack, an end-to-end smart energy, digital energy stack, where we run everything, we control everything from the front end in terms of the app, the user app, the platform that aggregates everything, to the hardware, as you have seen, and all the integrations and interfaces in between. Secondly, because of that deep integration across the stack and as well with the grid, we believe we can extract the most value from grid edge assets in terms of managing them, increasing efficiency, utilization even, and as a result, reduce energy and carbon consumption. And thirdly, we're part of two really world-leading organizations. On the one hand, you have Lysos, which we mentioned before, one of the world's largest solar PV project developers and operators, as well as BP, which is a fantastic organization to be part of, especially on the low carbon net zero energy side. I'm going to talk to you a little bit more now about our product and service offering and how that pertains to the topic of digital energy. So as labs, we really have multiple offerings in multiple sectors. So first of all, in the top left side, which you see here, we have the HEMS, which you've just seen before, our Tribe Hub, as we call it, which is for residential context and connects directly to the inverter, solar panels, and so on, which we'll see more about in a minute. Secondly, we can use the same or similar technology for industrial and commercial premises, be that shops, multi-site operations, schools, all the way to offices, where we can really establish a similar kind of connectivity, only that there you have more consumers, more energy consumers, you have charge points, you have more storage, so it gets much more interesting, much more complex, and really an opportunity to bring it together as well. Underpinning everything, what you see here in the top right quadrant, we have our own IoT platform, which is based on technology called UbiWorks, which we acquired a couple of years ago. That is really running both in the cloud as well as on our devices directly with constant synchronization and over-the-air updates. And then in the lower row, as you can see here, we then have the possibility, once we have installed the IoT platform, we have this grid and this network of connected assets. We can then deploy on top of this a VPP, a virtual power plant for distributed energy assets. We'll see more about this in a minute, as well as go to a level where we can optimize large energy generating assets, for instance, dynamic solar power plant optimization, as well as distributed energy and resource management. You can see them here in gray because these aren't things that we do today as we speak, but there are options for us and opportunities that we're actively exploring right now. Back to the beginning, so a little bit more about the HEMS, the Home Energy Management System. Imagine you have a house or property. It doesn't have to be a house, property of any kind that has, on the one hand, the generation, which you see here as the solar panels on the roof. It has ideally some form of battery storage, as well as an electric vehicle and an EV, and maybe some smart devices, smart appliances, smart plugs in the home. So what Tribe allows you to do then is to maximize the self-consumption of the storage you have, as well as, and then in order to then use that electricity when you're home in the evening, for instance, but also you can sell it to the grid when the tariffs are high. So we are integrated with a number of dynamic tariffs, dynamic time of use tariffs, so you can use your storage you have, both the battery as well as the EV, the storage in the EV for arbitrage opportunities in order to sort of manage flows from into the grid. Also, what you can do with Tribe, we'll see in a minute through the app, is you can automatically set it to save money, save carbon, increase your comfort, and you can also adjust settings for your home. For instance, you want your EV charge to 50% at least at 8 a.m. and your washing washed at 7 a.m. so you can hang it out. These are all things you can manage directly with Tribe and automate as much as possible. This is just very briefly a quick chart. It's actually here from Delta EE, which fits the purpose very well. So you can see Tribe sits in the middle. It connects both to the switchboard, to your distribution board at home, on the one hand with the metering device we have, but also talks directly to the inverter. For instance, we have direct connectivity, either Wi-Fi or a serial cable, and through the inverter it can then communicate with the battery as well. On the other hand, through Wi-Fi and wireless technologies, we can speak with smart appliances or smart-enabled appliances, for instance, a washing machine, air conditioning, water heating tanks, water storage tanks, lots of other devices, which can be then automatically managed by Tribe. last but not least, Tribe Connects has a connection to the cloud, either through Wi-Fi or 4G, and always gets updated with the latest weather forecast, electricity tariffs, and anything else that's useful from the Tribe cloud in order to really make the best management decisions in terms of the artificial intelligence that is running on the box. This is maybe an interesting topic as well. The Tribe itself is fully cloud connected, as all modern digital startups and technologies should be, but it runs also completely independently from the cloud. So if the Wi-Fi goes down, if there's no connectivity or there's any other problems, in that sense, we have a compute unit, very powerful, in the box itself, and it is fully operated with the same IoT system that runs in the cloud. So your energy management at home will just keep going in the same way as it has before, and then it will update with the cloud weather reports and any other data that is synchronized with the cloud as soon as the connectivity is back, or we do it through 4G. These are just, I'm not going to go through this in detail, just some impressions from our mobile app. Runs both on iOS and Android operating systems. So you can see on the left-hand side, there's really an opportunity to get a high-level view with the energy flows in the home. You can also swipe and prioritize, as you can see here, your energy consumption. So put the electricity that's generated by the panels into the storage, the local storage, the battery, or the EV, or put it into the grid. And in a similar way, you can see what your consumption is over time, how much you're spending in terms of pump, but also how much you've saved. And here on the right-hand side, you can see a little bit that the device level consumption, which we can measure as well through smart plugs, and the scheduling, which you can do through the app. So you can do as much manual as you want in terms of setting it up and scheduling, or you can just automate everything and say, just save me as much money as possible, or run it or save as much carbon as possible. This is just a quick image here. I'm not going to go through this in detail of the integrations we've done. So we really see Tribe, the Tribe Hub as the core device that really sits at the nexus, at the center of energy management in the home. You can really simplify it and say, you could simplify it and say Tribe is the smart assistant for home energy management. So on the one hand, we have lots of integrations with different tariffs in different markets in the UK and beyond. We have lots and lots of communication protocols we support in order to really cater and integrate a lot of different devices and equipment. We get lots of data from the cloud. We can do load optimization of all sorts of devices, from air conditioning to water storage tanks and specific appliances. We're integrated with a range of inverters, as well as energy storage devices. And as we speak, we're also integrating with the latest generation of Huawei inverters, which is something that we're really looking forward to being able to bring to the market. And last but not least, we support OCPP, EV charging protocols, and working on an EE-bus integration as well. Just to stay on the slide for a second longer, so the core value proposition of the Tribe Hub is really to manage all these different integrations. So our partners who we're working with, be they energy utilities, be they housing operators, landlords, or device hardware OEMs, they don't have to worry about it. They can rely on us for these integrations and deliver the best service possible on top of that. Now I have to accelerate a little bit, but I just wanted to give you a little flavor of other things we're offering and we can offer, which are based on a similar kind of stack, the similar technology, from IoT technology, the platform that underpins everything, to IoE, Internet of Energy, as well as the user apps you have on top, and of course the hardware. So one of these examples is energy management system for C&I, for commercial and industrial. As examples, you can see petrol stations, of course, now increasingly with charge points, all the way to airports on the other extreme. So there you can really deploy similar technology or Tribe hub-based technology in order to really get an idea of what's happening on the site, the monitoring, bring together all this information in a single platform, which we call Fleet Viewer, which is based on our Atlas system, as well as ultimately manage the key devices and sort of the key loads in order to, as before, improve the efficiency of the buildings, but also potentially deploy predictive maintenance and other smart digital algorithms. I wanted to talk to you a little bit just about the IoT platform we have, this is based, as I mentioned before, on UbiWorks technology, and it's really quite sophisticated in the sense that it's very flexible. It's in the cloud, but it can run on the sort of compute unit, which is based on an ARM processing technology, quite powerful for local sort of deployment. And it can connect to any sorts of devices you have in the home. We're constantly working on new integrations and new interfaces to get more appliances online, more devices online, get more information, and make better decisions, which can be automated at the hub level. And then, last but not least, what you also have, as I mentioned before, once you have deployed lots and lots of energy assets, be they generating assets or consuming assets, including storage, which is really a third category if we want. You have microgrids or larger grids at the country level and beyond. Really, the idea is in the industry that you want to connect all of these assets and bring them together in what is generally called a VPP or virtual power plant, which then serves to deliver certain services to the grid and to the operators, be they grid services, be they balancing services, frequency response, and so on. And what's really quite interesting is that maybe at the individual level, the device and appliances you have aren't always used and fully leveraged, because you can't consume all the electricity you have stored, or you need other electricity. But by connecting all of this up in a system like ours, or through a system like ours, you can really maximize the utilization of these assets and make the most of it also in financial terms, which is obviously a very interesting proposition. And just the last slide to sum up in terms of our value proposition. So I've talked a lot about the digital technologies which we deploy in the market, which is quite interesting, quite exciting. We have several hundred users on the platform now, and we're active in those three markets which I mentioned, exploring new opportunities and new technologies all the time. But really, at the end of the day, it comes down to the value proposition, the benefits for our partners. So be they distributors and installers who can use it to augment, aggregate their product offering, be they inverter, battery, and charger OEMs who can differentiate in the market with that and make the devices truly smart without having to worry about all the integrations that you find in the home and that are outside of the remit, to, as you see in the middle here, utilities and grid operators who can use our technology to have a much better interface and understanding to the customers and understanding of customer behaviors in order to offer better services to customers and lower the cost to serve, as well as facility managers and property developers who can benefit from it in terms of, again, differentiation, but also really to lower the cost to serve and lower the operating cost and the cost to operate the microgrids in new development, which is all possible with the kind of technology that I've spoken about today. And that was it from me. Thank you very much, and really appreciate the opportunity and hope to be back soon.
So we've come to the end of today's event. Thank you so much for tuning in and finding out what Huawei Digital Power is all about. We are looking forward to seeing you all in person very, very soon again. But until then, take good care and all the best.